Hi, my name is Sandhu with Dorse and Company, and today we're going to do a presentation on DOAS air source heat pumps from Greenheck. The Tempered Air Group over at Greenheck has released an air source heat pump which prompted the creation of this video. The option is available for RV and RVE line. I'll be going over some of the slides in this presentation as well as a walkthrough of some selection options. Several slides in this presentation have been taken from the Greenheck presentations from the past. So next, we'll go through the agenda. Basically in this video, we're going to cover the basics of an air source heat pump. What is an air source heat pump? What are some of the advantages? Secondary heat, what is it and when do you need it? And then we're also going to talk about the Greenheck line of air source heat pumps. What line is this offered in? How do we select it in caps? And what the submittals look like. So what is an air source heat pump? Air source heat pump is a direct expansion refrigeration system that provides heating and cooling. This might sound a little confusing, but I'll break it down into two different parts. First part, we're going to talk about direct expansion DX systems. So these typically contain compressors, condensing coil, expansion valve, and an evap coil. So these four items make up that DX system. The second part, which will be heating and cooling aspect of the system. The heating and cooling is controlled by a reversing valve. Essentially, it'll switch a system from heating or cooling depending on what is needed in the space. This happens by change of direction of the refrigeration flow in the system. To the right, there's a picture of a valve, what it looks like, and then there's a diagram of the air source heat pump system, which looks identical to the DX system, but with a reversing valve added. Typical standard DX system condensing coil is always rejecting, and the evap is absorbing the heat. With the air source heat pump changing directions, Greenheck revised their terminology on this. So when Greenheck's talking about indoor coils, they're mostly talking about the coil that's located in the unit, and then the outdoor coil is typically going to be the coil that's located on the exterior of the unit. So the air source heat pump overview, cooling mode, heat transferred from supply airstream to ambient outdoor air. The indoor coil is evaporating, the outdoor coil is condensing. And then it's going to be the other way around for the heating mode. So heat transferred from ambient outdoor air to the supply airstream. And then we're going to have the indoor coil is condensing, outdoor is going to be doing evap. So we're going to kind of take a look at this, look at the valve here and how it works. So what this valve contains is a U-shaped tube that kind of slides back and forth depending on what mode you need to be in, heating or cooling. So if we look at the left side, cooling mode, the U-shaped valve is over the right, and this is going to allow the compressor's hot gas to go through the valve and then come out to the outdoor coil. Then the indoor coil gas is getting sucked back into the compressor. So you'll see like that. And then the opposite is going to do the same thing when you're in heating mode. Hot gas from compressor goes to the coil, indoor coil, and the outdoor coil's cool gas goes back to the compressor. So that's how this reversing valve works when it's calling for heating or cooling. So here we have our diagram of cooling mode. We're going to have the compressor hot gas come out. It's going to go through the reversing valve, come into the outdoor coil, and the outdoor coil is going to be rejecting heat. So it comes down, expansion valve, and then we get into the indoor coil, and the heat is absorbed. And then go back to the reversing valve, back into the compressor. So this is going to be the same effect on the heating mode side as well. It's just going to be going the opposite direction. Indoor coil is rejecting heat into the supply stream, and the outdoor coil is absorbing the heat. You'll see that the system is exactly the same, just the reversing valve is kicked a different way. So some of the advantages: it's highly efficient and It's rated by the COP. Basically, COP is a ratio of the heat output in watts and over the electrical input in watts. So typically these air source heat pumps, COP is between 2 and 4, which translates to 2 to 400% efficiency, which if you go with a gas unit, you're only really going 80% efficient. So you can see the benefits of that already. So below there's a little graph of the energy uses, energy cost savings for different locations. You can kind of see that how different temperatures kind of affect the air source heat pumps performance. So you'll see Atlanta, Dallas, Seattle. You can see the different range. Atlanta's almost all the way up to 2,000, and then Dallas is close to 1,000, and Seattle's about 1,250. So you can definitely take a look at seeing how much savings are correlated with where you are. So next thing we got, there's no carbon footprint, which is huge in Seattle because we've got the new green initiative where they're trying to make all buildings zero emissions. So you're getting rid of a lot of gas units and stuff, going a lot electric, and so this is going to be huge for doing something like that going forward with the green initiative. It's safe and clean alternative to conventional heating. There's a potential lower first costs depending if you need secondary heat or not. So if you don't need secondary heat, this is always a good option. It's much cheaper. Secondary heat, we haven't really talked about it, so we'll cover that next here. Before I get into the secondary heating, I'm just kind of pointing out this air source heat pump heating performance. It's basically dependent on the ambient outdoor temperature. That being said, efficiency will decrease as the outdoor temp decreases. Take a look at the example below on how much difference there is between the heating capacities and the leaving air temperature. You'll see ambient outdoor temps at 47 with 117 MBH heating capacity, with leaving air temp at 90.3. And say it's 17 degrees outside, and it's gonna drop your efficiency down to 82 MBH heating capacity with the leaving air temp of 47.4, which is definitely not going to cut it, and that is basically why you're going to need secondary heat for cold climates. So a secondary heating source will be required to satisfy the indoor temp at set points when you do drop down into low temps. There are a few options you can select when you're doing this in caps. They include none, no heating, no secondary heating, indirect gas, hot water, or electric heat. So if you do pick none, or if none disappears and you want none, there's a reason why. It'll disappear if the unit is configured with 100% outside air and outdoor temps below 50 degrees. That's obvious because you got to have some sort of tempered air. Typically code calls out for like 50-55 degrees, and then partial recirc and outdoor temp is below 10 degrees. At these conditions, we're forcing you to use the secondary heat just because you're not going to be able to maintain a good, comfortable air temperature coming into the space. So that being said, there's going to be a defrost sequence involved with this, and the risk of frost formation on the outdoor coil and cold temps. To the right, there's a picture of one of our competitors' heat pumps with frost formed all over the outdoor coil. The air source heat pump in heating mode, the outdoor coil is evaporating, which is trying to absorb heat. With that, the surface of the coil gets extremely cold. And if there's any moisture on it, it'll build up, and the result will be frost and ice, which you definitely do not want. So the air source heat pump will require a defrost cycle. And what we have done to make this happen is we switch the system to cooling mode, which makes the outdoor coil want to reject that heat, which will heat up the surface of the coil, so no frost can build up. When it's in this mode, the secondary heat will be used to prevent any cold air delivery to the space. So we're going to talk about what line you can get this in. So the Greenheck air source heat pump, you can get in the RV series, RV 25 and 45, and then the RVE series, which is the RVE 40 and 85. Doesn't go any bigger because the air source heat pumps are only available from the 5 to 30 tons, which translates to about 800 to 10,000 CFM. Standard features on these, you got the inverter compressor as well as the lead EC outdoor fans. Now I'm going to take you through a general selection process. This is what the RVE design parameters tab looks like when you're selecting a unit. I'm sure you guys all seen this. You'll see the drop down of the heating and cooling type. There is an air source heat pump option, and if you select that one, on the heating side, the cooling side will autofill as well as air source heat pump, and then same goes if you're going to do that for cooling, the heating will change automatically. So some of the selection limitations, can't mount this indoors. Reason being, the heat is absorbed and rejected from the ambient outdoor temp, so it cannot be inside. Voltages that are 575 cannot be done. This being, we just couldn't find any 575 inverter compressors. And then elevation cannot be greater than 6,500 feet. That's just the manufacturer's inverter compressor limitations on that. So if the air pump or air source heat pump doesn't show up in the heating or cooling tab, it's probably because of one of those reasons. So you might want to double check that. So next tab you'll see is going to be heat pump tab. This is what it looks like. You'll see a few different sections. Top one, we got the cooling section, which is fairly similar to all the other DX selections we've done before. There isn't anything new going on here, so you just gotta kind of go through and select what you want. What kind of reheat methods, calculation method, leaving, dry and wet bulb temps. The heating section, I'll get into that a little more on the next slide. Options, you can select a 5-year extended compressor warranty, and then the other two options are grayed out just because, as I mentioned before, those are standard. Inverter scroll compressor and then the lead EC outdoor fan. And then you'll see the performance review. Once you kind of populate some selections, you can click on them down at the bottom, and it'll show you a brief little performance review, so you can easily select a unit. So the heat pump tab and then that little heating section, we're going to talk about this, and this will cover the secondary heating. There'll be a drop down here with like following options of secondary heat. We discussed before, it's none, gas, hot water, electric. Once again, none will disappear if you're at 100% outside air and less than 50 degrees, or partial recirc with outdoor temps below 10 degrees. Outdoor air temp is important because it's used to size the heating capacity. So it should equal the lockout temp used on site. It's got to be greater than or equal to the winter outdoor dry bulb, as well as the absolute min is 10 degrees, no lower than that. So this is what the secondary heat tab will look like. If you've selected some sort of secondary heat, whether it's electric, hot water, or gas, in this case, this is what the electric one will look like. One thing to focus on is the heating sizing drop down, which is the supplemental here. You can go through. There's two different options. One being it being supplemental heat or backup heat. So the supplemental heat will it'll work as secondary heat to work at the same time as a heat pump, whereas the backup heat will not. So if the air source heat pump is off, the backup heat will kick on, whereas supplemental, they'll work together. So heat sizing for gas and water is always supplemental. This option should be populated when you select it, the type of supplemental heat. Heating for the electric, it can be either supplemental or backup. So heating heat sizing for 100% outside air will always be supplemental, just because 100% cold outside air needs to be heated by the electric heater during this air source heat pump defrost cycle. So forcing it to be supplemental will allow them to operate at the same time. So getting into the submittals here, you can see on this page is the primary heat, secondary heat specs. So you'll see cooling, heating's right here, secondary's right here. So you can see all the different options and all the different data that it'll spit out for you. Next is, it's going to be showing the efficiencies of the air source heat pump, primary heat and secondary heat specifications. So if this unit is 100% outside air, it's gonna show you the cooling efficiency and heating efficiency, and the ISMRE and the ISCOP. And then if we're partial recirc, the heating and cooling is going to be shown in the EER and IEER, or COP at 17 degrees and COP at 47 degrees. So you'll see at the bottom everything's calculated per ASHRAE 90.1. If you meet compliance, you'll see a nice little check mark there, which is always nice to see, just to confirm that you got everything correct. Next page you'll see is the heat pump performance stuff. You'll see the coil information, what the coil model is, compressor details, how many there are, electrical data, all that good stuff, cooling specs and heating specs of the primary heat specs and cooling specs as well. So those are all good information to have when you need to do a submittal. To continue that, whatever you did with your secondary heat performance, where you can see this one is hot water, you can see the water percentage, flow rates, capacity, all that good stuff, and then you can see the hot water coil model there as well. So everything's pretty much listed out part by part, piece by piece, easy to access, easy to see. And then finally, just to kind of wrap things up here, we got an air source heat pump, uses refrigeration to provide both cooling and heating. Reversing valve switches refrigeration flow direction, so that's how you get the heating or cooling aspect of it. In cold outdoor conditions, the air source heat pump loses capacity and may even require secondary heat. So remember, keep that in mind. Air source heat pumps can operate down to a minimum of 10 degrees outdoor temps. Anything lower than that, you're going to have problems. And then I think the compressors are also rated only to be to 10 degrees as it is per the manufacturer. So air source heat pumps in caps, there is a new heat pump and secondary heat tab, which we went over. So those are probably two most important things when selecting the heat pump function. And then we also covered the new submittal pages and what they entail. So if you have any questions, comments, feel free to leave them in the comments section below. If you look in the description, there's a few links to our websites, LinkedIn, Facebook, all that good stuff. Give us a like, give us a follow, and stay tuned for the next video. Thank you.